when you're differentiating a function, you can repeat that process any number of times. For example, when you're finding the second derivative, you just need to differentiate the first derivative. When you're finding the third derivative, you just need to differentiate the second derivative. And this process can continue n number of times. Okay? So in example 1, we are required to find the first, second, third, fourth, and fifth and sixth derivatives of this function. So the first step will be to find the first derivative. So the first derivative of this function will be 5x to the power 4 plus 9x squared minus 2. The second derivative of this function will be 20x cubed plus 18x. The third derivative of this function, now instead of using the hash marks, we'll use 3 at the top to represent the third derivative. So the third derivative of this function will be 60x squared plus 18. The fourth derivative of this function will be 120x. And then the fifth derivative of this function will be 120. And the sixth derivative of this function will be 0. Okay? So that's how you find the higher derivatives of this function. And you can see that derivatives after sixth derivative will just be 0. Okay, let's look at the second example. What's true about the nth derivative of this function? What that means is we need to differentiate this function up to the fourth derivative and then observe the pattern before you can generalize. So, the first derivative of this function will be 3x squared plus 6x plus 2. The second derivative of this function will be 6x plus 6. The third derivative of this function will be 6. The fourth derivative of this function will be 0. Now, what does that mean? It means that for n when n is greater than or equal to 4, the nth derivative will equal to 0. Like, for example, what I mean here is the fifth derivative will be 0, the sixth derivative will be 0, and so on and so forth. Okay? Example 3, find the first 4 derivatives of this function and then write a generalization, which basically means a rule for finding the nth derivative of this function. So the first step is we can start by finding the first derivative, second derivative, at least the first 4 derivatives. Then you can be able to observe a pattern. Then you can come up with a rule. So the first derivative will be dy over dx, which will be e to the power x. Now, how you have to apply chain rule. The derivative of negative x is negative 1. So negative 1 e to the power negative x. The second derivative of this function will be e to the power x. And then again, derivative of negative x will make negative 1. And negative 1 multiplied by negative is positive, so plus e to the power negative x. The third derivative of this function will be e to the power x minus e to the power negative x. The fourth derivative of this function will be e to the power x plus e to the power negative x. So we can see that there's actually a pattern here. It's like the first derivative is equal to the third derivative, and those are odd powers. And the even powers, like for example, the second derivative is equal to the fourth derivative. So we can be able to generalize this. And this is the pattern, because these are powers of -1, the coefficients of e to power negative x. We can write this as e to power x minus or plus -1 to power 1 e to power negative x, which will basically give you the same thing. Here it's same as e to power x plus -1 squared e to power negative x. Here we have e to power x plus -1 to power 3, which will be -1 e to power negative x. And these are some of the things that you have to observe, especially with the higher derivatives. You have to observe some patterns and find ways of generalizing those patterns. So this will be e to power x plus -1 to power 4 e to power negative x. Now, obviously, what that means is, and if you look at the pattern here, these powers, we can be able to come up with a generalization of the nth derivative, okay? Which means that the nth derivative of this function, so the nth derivative of this function will be e to power x plus -1 to power n e to power negative x.